Hello, I'm Alan from WannaGet8, and today I want to show you how you can accurately mill in any machine, even with backlash. And please kindly donate through PayPal account LSJR@gmail.com for sustainability. Even a dollar will be highly appreciated. Hello, I'm Alice from WannaGet8, and today, once again, I wanted to make something for the rotor table out of this old padlock. Unfortunately, this got a couple of holes, big holes, and therefore it wasn't usable. So my today's project was just like a practice. So I just discovered a trick, which I know that a lot of machinists, they know it already, but I think it's worthwhile talking about it once again. And this is it's interesting because today, for the first time, I was able to cut to mill this piece to exactly the size which I wanted, and I wanted to get 13.74 millimeters, and I have achieved exactly that dimension. And what I did is that I first used the roughing tool, which is somewhere around. I just put it here. The roughing tool. Just put it for the benefit of new machinists who may not know it's a roughing tool. So this is a roughing tool. It's just an end mill, but it has something like, it's not thread, but you can see these grooves, and therefore the cut is rough. You can't get a smooth finish like this with this one. And this one you use to cut the bulk of the metal before you change the tool to the finishing tool and finish your workpiece to the required dimensions. So what I did, I used this one, and I started cutting the extra material from this piece, and then I changed to putting my finishing tool there, and I milled just a little bit of the depth, which is bigger than the target depth. And then you take off your workpiece, you use a vernier caliper, here it is, and you measure this thickness. So this will be the current thickness of a workpiece, and what you do, you take your final or the target depth, you subtract it from the current depth. So take the current depth and subtract the target depth, and the difference will be the amount of cut which is required to make your workpiece get milled down to the required depth. So remember the last cut. When you do the last cut, you just turn this turn wheel, and you did your last cut, which, as I said earlier, is a little bit bigger than the target depth. And that difference, which we've just calculated, you turn the amount of this difference, and this means that this end mill will go down exactly to the size it is supposed to cut, to the target size of your workpiece. And because when you are doing the last but one cut, you are turning this wheel in this case it is clockwise direction, and when you put this difference, you put when you're turning this to lower this to the required depths, it is moving in the same direction. And this is very important, because doing so you will avoid backlash, because backlash happens when you're turning in one direction and then you turn in the opposite direction. But because you're turning in the same direction, it means that this will be lowered exactly that difference between the target depth and the current depth. And in doing so, you achieve a very, very accurate cut, as I did today. 13.74, exactly is what I've got. So, and please kindly donate through PayPal account LSJR@gmail.com for sustainability. Even a dollar will be highly appreciated.